There is a fault running directly under the skyscrapers of downtown Los Angeles, and most of the millions of people who live and work above it have never heard its name. It is called the Puente Hills Thrust. It runs more than 25 miles out under the San Gabriel Valley, and it is a blind fault, which means it never reaches the surface. Nothing on the ground marks where it is. The United States Geological Survey says a full break could kill 3,000 to 18,000 people and cause $250 billion in damage. But here is the detail nobody puts on the news. This fault already broke once, and when it did, nobody even knew it was there. It moved for the first time in modern memory in 1987, and it took the city 12 years to figure out what had actually happened. Los Angeles. October 1st, 1987, 7:42 in the morning. People were driving to work. Kids were walking into school, and the ground under the San Gabriel Valley jumped. The Whittier Narrows earthquake was a magnitude 5.9. By earthquake standards, that is medium. It is not the big one. It is not even close. But it killed 8 people, injured around 200 more, and damaged close to 10,000 buildings. It caused $358 million in damage in 1980s dollars. A 3-story parking garage collapsed outside a department store on Whittier Boulevard. A student at California State University, Los Angeles, was killed when a slab of concrete fell in a campus parking garage. A Southern California Edison worker died in the San Gabriel Mountains. Old brick buildings in the old downtowns of Whittier, Alhambra, and Pasadena cracked open and partly fell down. The spot where the 5 and the 605 freeways meet had to be closed when chunks of concrete broke loose. And here is the part that should stop you. Nobody could say which fault did it. The quake came from a thrust fault that no map had ever shown. It never reached the surface, so there was no crack in the ground to point to, no torn road, no line across a field. The energy came from somewhere deep under the valley, and then it was gone, and the fault that made it went right back to hiding. Most people never heard that part. The 1987 quake is remembered as a bad morning in Whittier. What it actually was a warning shot from a fault that science had not found yet. 7 years later, it happened again, on a different hidden fault. January 17th, 1994, 4:30 in the morning. The Northridge earthquake, a magnitude 6.7, tore through the San Fernando Valley. It killed 57 people, injured more than 8,000, and caused well over $20 billion in damage. It too came from a blind thrust fault that nobody had mapped before it broke. Twice in 7 years, Los Angeles had been hit hard by faults it did not know it was sitting on. So, a team of scientists set out to find the one under the city. This is the part that takes real detective work, because you cannot just walk out and look at a blind fault. There is nothing on the surface to see. What the scientists used instead was data the oil industry had been collecting for decades. Records from wells drilled deep into the basin. Echo surveys, which bounced sound waves off the rock layers far underground and read the echoes like an ultrasound, and the exact spots of past earthquakes mapped in 3 dimensions. In 1999, a Harvard geologist named John Shaw and an earthquake scientist from the Scripps Institution of Oceanography named Peter Shearer put the pieces together and published the answer. They found a single connected fault running from northern Orange County up under Whittier and Santa Fe Springs, across the San Gabriel Valley, and straight under downtown Los Angeles. They named it the Puente Hills Thrust, and they showed that the 1987 Whittier Narrows quake had ripped open just a small piece of it. The fault had been there the whole time, under the freeways, under the houses, under the towers, for at least 12 years after it broke in 1987, and for millions of years before that. And here is the detail almost everyone missed when the story ran. The 1987 quake used up only a small part of the fault. By 2002, when Shaw and his team had mapped the whole thing, they could see it was more than 40 kilometers long, made of 3 connected ramps. The piece that moved in 1987 was a thin slice of one of them. The rest of it has not moved in a very long time. Now zoom out and look at where this thing actually runs. Picture the Los Angeles Basin from above, the towers of downtown, the flat spread of the San Gabriel Valley, the streets of southeast Los Angeles County, places like Norwalk, Downey, and Southgate. The northern edge of Orange County, all of it sitting on what looks like solid, flat ground. It is not solid, and it is not flat underneath. The Puente Hills Thrust is shaped like a ramp, tilted under the city. It does not stand straight up. It leans, tilting at about 27 degrees down into the earth. Near the University of Southern California, just south of downtown, The top of that ramp sits only about 2 miles below the surface. About 4 miles under the downtown high-rises, the fault is right there beneath the foundations. Follow it to the northeast and it dives deeper. Until under the 210 freeway area, it is roughly 10 miles down. So how does a fault you cannot see do so much damage? Two things stack on top of each other. The first is the fault itself. A thrust fault is a break where one slab of rock is being shoved up and over another. The Puente Hills thrust is being squeezed from the sides, a little more every year. The rock above it cannot break the surface, so instead it folds. Slowly, over hundreds of thousands of years, those folds have built an entire mountain range under the city. You cannot see it. It is buried under sand and gravel dropped by ancient floods. But it is there, nearly 2 miles tall, hidden under the flat streets of Los Angeles. The second thing is the ground that downtown is built on. The Los Angeles Basin is a giant bowl of soft mud and sand, thousands of feet deep. And that soft ground does something dangerous in an earthquake. When the shaking arrives, the basin acts like a bowl of jelly. James Jackson, a professor of geophysics at the University of Cambridge, once described this kind of ground in plain words. It is, he said, like being built on jelly on top of something that is wobbling. The waves come in, hit the soft sides of the bowl, and instead of passing straight through, they bounce around inside and get trapped. A jolt that would last a few seconds on hard rock can roll on and on inside the basin. Thomas Jordan, then the director of the Southern California Earthquake Center, has said that a magnitude 7.5 on the Puente Hills thrust would be close to a worst case for downtown, with shaking that could last more than a minute. More than a minute. Picture standing in a glass tower 40 floors up while the building moves for a full minute. That is what the models keep coming back to. Picture a normal Tuesday morning. The sidewalks downtown are full. Elevators are running. Somewhere on the 40th floor, someone is pouring coffee. The first thing they would feel is not a sharp jolt, but a slow roll, the floor moving like the deck of a boat, and then it does not stop. 10 seconds. 20. The models say it could keep going past a minute. That is long enough for the welds and the bolts and the old concrete to find out exactly how strong they really are. James Dolan is a professor of earth sciences at the University of Southern California, and he was part of the team that found the fault. He has spent his career studying the faults directly under the city. He does not soften it. If you set out to design a worst-case scenario fault for Los Angeles, Dolan has said on the record, you would come up with the Puente Hills thrust. He has also put it another way. This is a very, very large fault, located in about the worst possible place you could imagine for a fault beneath Los Angeles. The reason is simple. The famous San Andreas Fault is bigger and it can make a larger earthquake. But the San Andreas runs out along the edge of the region, through empty desert and mountains, far from most people. The Puente Hills thrust runs through the middle of everything. A smaller quake in the wrong place can do more damage than a bigger quake in the right one. In the models, a magnitude 7.5 here would do as much damage as a magnitude 8.0 on the San Andreas, even though the San Andreas quake releases many times more energy. If you are finding this useful, subscribe. We cover earthquakes, water crises, and earth science events like this every week with the full picture you need to actually follow what is going on. Because while the fault sits quiet, the city keeps building on top of it. The clock was already running. Los Angeles just could not hear it. Here is how the damage would stack, layer by layer. First, the towers. Downtown Los Angeles is a forest of high-rise buildings, many of them tall enough that a full minute of slow basin shaking is exactly the kind of motion that strains them most. Tall buildings sway in long, slow waves. The trapped waves in the basin are long and slow too. That matches the dangerous part. And there is a hard lesson hiding in those towers already. After the 1994 Northridge quake, engineers went looking inside modern steel high-rises and found something they did not expect. The welded steel joints that hold the frames together had cracked, sometimes deep inside the building, sometimes with no sign of it from the outside. The buildings looked fine and were not. Second, the old buildings. This is where it gets worse. Engineers have long known that a certain kind of building, made of older concrete poured before modern earthquake rules, can simply fall down in strong shaking. The city of Los Angeles knows it too. In 2015, it passed a law forcing owners to strengthen them. The city's own count is that around 1,500 of these brittle concrete buildings stand inside city limits. A separate count put the number of at-risk concrete buildings at more than 1,200. Alongside nearly 13,000 weak wood frame buildings with soft, open ground floors. Owners were given up to 25 years to fix them or tear them down. Years into that window, most of the concrete buildings still had not been finished. So the city found the fault, found the buildings most likely to come down on top of it, and gave everyone a quarter of a century to deal with it. Third, the people pushed out of their homes. The United States Geological Survey loss study, led by scientist Edward Field, ran the numbers on a full Puente Hills break. It figured between 142,000 and 735,000 households forced from their homes. Tens of thousands more would need emergency shelter the very same night. Fourth, the roads and pipes. The basin is crossed by freeways, water mains, gas lines, and power lines, much of it old and stacked right over the fault. The same study figured 30,000 to 99,000 tons of rubble. That is the kind of mess that blocks roads and slows every rescue stuck behind it. Fifth, the money. The total money lost in that study came out between $82 billion and $252 billion. The scientists wrote plainly that a full break would be the most expensive disaster in United States history. And then, years after the fault was first mapped, a second study made it worse. In 2017, a team that again included John Shaw published a finding in the journal Geology. They had measured how fast the western part of the fault, the part directly under downtown Los Angeles, has been moving over time. And the rate was not steady. It had sped up. From about 0.22 millimeters a year in the distant past to about 1.33 millimeters a year more recently. That sounds like nothing. It is not nothing. A faster slip means the strain that drives earthquakes is loading onto the fault faster than the older models guessed. The scientists wrote that this creates, in their words, an evolving and potentially increasing seismic hazard to metropolitan Los Angeles. And the fault is not silent. In March of 2014, a magnitude 5.1 quake hit near La Habra on the Puente Hills system, followed by more than 100 aftershocks. It pushed about 100 people out of their homes and rattled a wide stretch of the region. In 2024, a group of small quakes lit up again just beneath the main fault. James Dolan was careful about that group. "These are very small quakes," he said, "and small quakes do not always mean a big one is coming." That is the honest answer. A handful of small quakes near a large fault is not a countdown, but they are a reminder that the fault is still there, still loaded, still able to do more. So how often does the big one come on this fault? That study by Dolan and the Southern California Earthquake Center found that the Puente Hills thrust has made at least 4 major earthquakes in the last 11,000 years. 4. That is the deep record, written in the folded rock under the city. Here is the part that cuts both ways. Unlike the San Andreas, which makes a big quake roughly every century or two, the Puente Hills thrust goes off only every couple of thousand years. So in any single year, the odds are low. That is the good news. The bad news is what a couple of thousand years actually means. It means the strain has been building on the main fault for a very long time. It means the fault is patient. And it means that when scientists say it will almost certainly make another major earthquake, they are not guessing. They are reading a record that already happened 4 times. People really need to be ready for a very, very large earthquake, or earthquakes, in Los Angeles' future, Dolan has said. It is going to happen. We do not know when. None of this is a guess about what soft ground does in a big quake. It already happened, and not far away. On the morning of September 19, 1985, a magnitude 8.0 earthquake struck off the coast of Mexico, more than 200 miles from Mexico City. By the time the waves reached the city, they should have been weak. They were not. Mexico City is built on the bed of a drained lake, and that soft old lake bed caught the shaking and made it stronger. The ground in the center of the city moved about 5 times harder than the firmer ground at the edges. Hundreds of buildings collapsed, most of them in the middle range of 6 to 15 stories because their natural sway matched the slow rhythm of the trapped waves. More than 10,000 people died from an earthquake whose center was hundreds of miles out to sea. That is the same physics waiting under downtown Los Angeles. Except the Puente Hills thrust is not hundreds of miles away, it is directly underneath. And that distance is everything when it comes to warning. Mexico City now has an early warning system that works exactly because its big quakes start far out at sea, which buys the city tens of seconds before the shaking arrives. Los Angeles has a warning system too, called Shake Alert, but a quake that starts right under downtown gives almost nothing to warn with. The shaking begins where the people already are. There is no head start when the fault is beneath your feet. That is where the science leaves us. with the questions stacked one on top of another. When does a fault that goes off every couple of thousand years finally go off, when nobody can read the exact date? Why is the slip under downtown speeding up, and what does that change? How do you strengthen a city center that was built tall and packed before anyone even knew the fault was under it? And how do you warn people about a quake that gives no warning, from a fault that leaves no mark on the surface to point to? Nobody can answer the first one. The data does not say when. It only says that the strain is real, the fault is loaded, and the record is clear. For now, downtown looks exactly like it always does. The towers catch the morning light, the freeways fill up. Millions of people drive in over a fault most of them have never heard of, park under glass and steel, and go to work on top of a mountain range nobody can see. 2 miles under the city, the rock is still bending. The fault is still locked. And the strain that will one day move it is still building. A fraction of an inch a year. In the dark, under the towers, under the freeways, under everyone who will never feel it coming until it does.